The HorizonCube is a step-change technology that enables a drastic improvement in understanding the geological meaning contained in seismic data, like 3D sequence stratigraphy, improved geological models, well correlation, low-frequency modeling. In this exercise, we will show how to create a continuous data-driven HorizonCube in order to understand the depositional history of propagating system using the principles of seismic sequence stratigraphy. Open the HorizonCube from Processing, HorizonCube 3D, or from the icon. Select Create HorizonCube under Processing and go. Select the horizons that will be used as input for the HorizonCube creation. Demo 1 FS4, Demo 4 Truncation, and Demo 6 FS8, and OK. There are two modes in the HorizonCube creation. The data-driven mode, which creates an HorizonCube guided by the steering cube computed from the seismic data. Therefore, it will follow the geometry of seismic reflections. It is the preferred mode to build accurate subsurface model. The second mode is the model-driven mode, which is a way of slicing the seismic data relative to the framework. There are three model-driven submodes: linear interpolation, parallel to upper, and parallel to lower. So select Data-Driven Tracking, go to the setting, select as a steering data, steering FFT225 MF113, and OK. Start at the center, check the Apply to All Packages option. That will apply these parameters to all the packages. Processing parameters can be optimized, like spacing, start position, number of iteration. Keep the default and cancel that window. OK. Constrain the area subselection between 400 and 450 inline range. Keep the crossline range the same, and OK. Then give an appropriate output name for the HorizonCube. We will call it HorizonCube FFT225 MF113. Ensuring the name contains all important information about the input data and parameters. And hit run. The batch processing finish, so we can close the progress viewer window and the other HorizonCube creation windows. Now display the new created HorizonCube. Right-click on Inline, Add and Selected Data. Under Store, we select Deep Steered Median Filter, and OK. Right-click on the Inline 425. Add HorizonCube Display. Select the new created HorizonCube FF225 MF113 and OK. You can optimize the display parameters of the HorizonCube by right-clicking on the HorizonCube display properties, like fill between lines, line width, and other parameters. Keep these default and close the window. Open the HorizonCube slider from the HorizonCube icon, move it to the side. We can change the color bar for the seismic to grayscale, for example, and the HorizonCube color bar to HorizonCube. Zoom in the area of interest. Observe and QC the results of the HorizonCube by moving the top slider and base slider. The HorizonCube slider is a very useful tool to investigate the data and make a detailed observation of the depositional history of the sedimentary basin. Observe the presence of gaps in the prograding clinoforms. This is due to the HorizonCube being created with only one iteration. Iteration can be added at a later stage. Now we will add more iteration. Open the Control Center, under Tool, add more iteration, and go. The input HorizonCube, pick the active HorizonCube that we just created. The first column, iteration finished, show how many iterations have already been processed, one in this case. The tracked horizon events from previous iteration will never change. Only new events will be added between existing ones. Leave the extra iteration option to 1 for each package and save with a new name. We'll keep the same as the input HorizonCube and add 2 iteration as extension, and OK. The batch processing finished, so we can close the progress viewer window and the HorizonCube creation as well. Change the active HorizonCube by right-clicking on the HorizonCube in the tree, select HorizonCube and select the new created HorizonCube with 2 iterations. Only one HorizonCube can be active at any time in OpenDetect. Change the HorizonCube color bar to rainbow for better visualization. Notice that the gaps have been filled by adding more data-driven horizon during the second iteration. Further gaps can be filled by adding one or more iteration if necessary. In this next exercise, we will create a continuous and data-driven HorizonCube based on inversion algorithm. Open the HorizonCube Control Center from the icon. Under Processing, select Create HorizonCube and go. Keep the same horizon selection as before, Demo 0, Demo 4, and Demo 6. Optionally, folds can be selected. This time, we will create data-driven HorizonCube using the inversion-based algorithm. Select the setting for the uppermost package and set the steering data to PCA 111 and OK. Keep the default parameter initial model type proportional, sampling at maximum thickness 4 milliseconds, start at maximum thickness. Apply to all packages. Option will set the same setting for all packages. Select processing parameters. If faults are available and the option is toggled to yes, fault dip will be calculated from interpreted fault planes and merged with the reflection dips from the steering cube. Confidence weight can be assigned to the steering cube. Planarity is a good confidence measure that can be calculated here or from the fault and fracture plugin. If confidence weight is selected, the confidence power becomes active and increases the contrast between the planar and non-planar features. The number of horizon updates are generally between 10 and 20. The number of CG solver iterations are used to solve the gradient equations. And finally, we can apply a preconditioning smoothing to reduce the spike in the output horizon. Keep the default and close this window. And OK. Constrain the processing area from the subselection to 400-450 inline range. And OK. And type a new HorizonCube output name. We'll call it inversion-based HorizonCube. And press Run. The processing finished, so we can close the Progress Viewer window and the HorizonCube windows as well. Then add the inline 425 and select the 4 deep stirred median filter. Right click again on the inline 425 and add HorizonCube display. If it's not the right HorizonCube which has been displayed, right click again on the HorizonCube and select HorizonCube. Then we select the inversion based HorizonCube that we just created. For a better visualization, you can change the color bars by right-clicking on the HorizonCube and go to the color bar and select HorizonCube color bar. Then on the Seismic, right-click and change to gray scale. Observe and QC the HorizonCube by using the HorizonCube slider. By moving the top and base slider, it allows us to investigate the data and make detailed observation of the depositional history of the sedimentary basin. As in the previous exercise, we observe some gaps. So we will use a different method to fill the hole by taking some event from the HorizonCube and recomputing the packages using the horizons. We will use the horizon slider to locate the event defining the gaps from this HorizonCube. Start with the top and move the slider down. Is about 85. Then similarly the base slider, move it up. It's about 91. Open the HorizonCube Manager and make a copy of the inversion based HorizonCube as we will be editing this one. It is the last icon. Keep the same name and just add backup. And OK. With the refresh, we can see now that we have a new HorizonCube with the backup extension. Now we will extract the event 86 and 91, which are the limit of the gaps, from the inverted based HorizonCube. Click on before the last icon, switch off all the events and select only event 86 and 91. The base name will be set as a prefix with an automatically generated suffix. So we just type invert and OK. Then close the Manage 3D HorizonCube. Now we are ready to modify the existing HorizonCube using these two extracted events, 86 and 91. Open the HorizonCube Control Center 3D. Ensure we have the inversion-based HorizonCube selected. Go to Tool, select Modify, Recalculate HorizonCube, and go. Ensure inversion-based HorizonCube selected. Read Horizon, then select the new extracted event 86 and 91 and OK. Choose as action Keep for the first package and Compute for the rest of the packages. Ensure that the 3 packages for the compute have the same algorithm, which is data-driven inversion. Depending on the nature and data quality, you might want to choose different algorithm and setting for each package and run. The processing is finished, so we can close all the windows. We can reload the HorizonCube inversion-based HorizonCube. to refresh. Notice that the gaps have been filled now. This concludes this exercise where we show how to create a continuous and data-driven HorizonCube based on tracking and inversion algorithms to understand the depositional history of prograding system using principle of seismic sequence stratigraphy.